Have you ever opened Civil 3D and felt overwhelmed by all the windows, tabs, palettes, and settings? In this video, I'm going to show you the most important parts of the Civil 3D interface so you can confidently navigate any project. By the end of this tutorial, you'll know how to find Civil 3D objects, manage drawing settings, customize layers, use Toolspace, and navigate the ribbon like a professional. Let's jump right into Civil 3D. Let's start by taking a look at a typical Civil 3D workspace. When I open this sample drawing, several major components appear. At the center is the drawing area. This is where we'll create and edit all our engineering objects. At the top is the ribbon. On the left side is Toolspace. Floating on the screen, we may also have Panorama and tool palettes. Now here's something important. Many beginners spend most of their time drawing. Experienced Civil 3D users spend most of their time managing data. Civil 3D is fundamentally a database that happens to draw things, every point, every surface, every alignment, every corridor. They're all stored as intelligent objects. The place where Civil 3D manages these objects is Toolspace, which brings us to our next topic. Toolspace is arguably the most important component in Civil 3D. You'll use it every single day. Toolspace contains 4 tabs: Prospector, Settings, Survey, and Toolbox. Let's start with Prospector. Think of Prospector as Windows Explorer for Civil 3D. Everything inside your drawing is organized here. Notice under Open Drawings we can see points, point groups, surfaces, alignments, profiles, corridors, pipe networks, parcels, sample lines, section views, and many other object collections. One of the most powerful features of Prospector is object navigation. Let's say someone tells you, check the alignment. Instead of zooming around the drawing, searching for it manually, simply expand Sites and Rows Acres. Then Centerline Alignments, find Alignment, right-click, choose Zoom to. Civil 3D instantly locates it. This works with virtually every Civil 3D object. By the way, this sample drawing can be found in the description box below, so you can practice with me. Imagine working on an airport project containing hundreds of alignments and thousands of survey points. This feature alone can save hours. Another thing many users overlook is right-click functionality. AutoCAD users often rely heavily on command lines. Civil 3D users rely heavily on right-click menus. Nearly every object contains useful commands hidden inside these contextual menus. If you're not right-clicking, you're probably missing half the software. At the top of Prospector, you'll notice a drop-down menu. This controls whether you're working in Active Drawing View or Master View. Active Drawing View shows only the active drawing. This keeps things simple and uncluttered. Master View expands the information available. In Master View, you'll see Projects, Drawing Templates, Data Shortcuts. Other open drawings, this becomes extremely useful when working on large projects involving multiple files. For example, imagine designing an airport expansion. You may have one drawing for grading, one drawing for roads, one drawing for utilities, one drawing for drainage. Master View allows you to see and manage information across all these drawings. Let's talk about data shortcuts. Data shortcuts are one of the reasons Civil 3D became so popular for collaborative projects. A data shortcut creates a reference to an object located in another drawing. For example, your survey team creates an existing ground surface. Your roadway designer needs that surface. Instead of copying the surface into another drawing, Civil 3D references it. Now everyone works from the same source. If the survey team updates the surface, everyone sees the update. This reduces duplication, reduces errors, and improves collaboration. When working on large infrastructure projects, data shortcuts are often the backbone of the entire workflow. Let's switch to the Settings tab. The Settings tab controls how Civil 3D behaves. Right-click the drawing name. Choose Edit Drawing Settings. Several tabs appear. Let's focus on the most important ones. Units and Zone. This is where you define your coordinate system. For example, if you're working in Quebec, you may use NAD 83 Quebec Zone 8. Civil 3D contains hundreds of coordinate systems from around the world. Selecting the correct coordinate system ensures your project matches real-world coordinates. You can also define metric or imperial units, drawing scale, insertion scaling, coordinate transformations. This may seem like a small step, but choosing the wrong coordinate system can create major issues later in a project. Many experienced engineers verify coordinate settings before doing anything else. The next tab worth understanding is object layers. Civil 3D automatically assigns objects to layers when they're created. For example, alignments, profiles, surfaces, parcels, pipes networks. Each can have its own default layer. Many firms follow the national CAD standard. Others create custom company standards. Suppose your alignment represents a sanitary sewer centerline instead of a road centerline. You can modify the default layer assignment before creating the alignment. Doing this properly ensures drawings remain organized and consistent across the entire company. One thing to remember, changing the default layer affects future objects. It doesn't automatically move existing objects. That's an important distinction for beginners. Now let's look at ambient settings. This is one of the least understood areas of Civil 3D. Ambient settings control units, precision, label, formatting. How many decimal places should elevations display? 1, 2, 3. What about station formatting, distance formatting, angle formatting? All of these settings are controlled here. Tooltips are another useful feature. When I hover over a Civil 3D object, information automatically appears. Surface elevations, station and offset values, alignment information, profile data. For beginners, these tooltips are incredibly useful. For advanced users, they can sometimes become distracting. Fortunately, Civil 3D allows you to customize exactly how they behave. Let's finish with 3 components that many users ignore. First, Toolbox. Toolbox is a central location for reports, automation tools, VBA macros, and custom company utilities. Many firms add their own reports and productivity tools here. Instead of creating custom ribbon buttons, they centralize everything inside Toolbox. Next is Panorama. Panorama acts as Civil 3D's information center. Whenever Civil 3D needs to display large amounts of data, Panorama often appears. You'll use it for surface analysis, profile editing, volume calculations, event viewer messages, and data review. My recommendation, keep Panorama visible whenever possible. Civil 3D frequently communicates important information through this window. Finally, let's talk about the contextual ribbon. Watch what happens when I select a label. The ribbon changes. Now I'll select an alignment. The ribbon changes again. Now I'll select multiple object types. A new contextual tab appears. This dynamic behavior is one of the biggest productivity improvements in modern Civil 3D. Instead of searching through dozens of commands, Civil 3D automatically presents tools relevant to the object you've selected. The more you use Civil 3D, the more you'll appreciate this feature. Congratulations, you now understand the core components of the Civil 3D interface. Today we covered Toolspace, Prospector, Settings, Toolbox, Panorama, Contextual Ribbon. In the next tutorial, we'll start working with actual Civil 3D objects and begin building a real project. If you found this video helpful, please like, subscribe, and let me know in the comments what Civil 3D topic you'd like to learn next. Thanks for watching, and I'll see you in the next Civil 3D tutorial.